Hey guys, this is Sergey, and you're watching Dissecting the Code. .NET is a managed environment, and one of the key benefits is an automatic memory management. As we've seen before, there are some cases when you need to think about memory leaks, but in general, the runtime does an excellent job of deallocating objects that are no longer needed by the application. But memory is not the only resource used by an application. There are many so-called native resources, such as file handles, sockets, database connections, mutexes, and other operating system or third-party resources whose lifetimes are controlled by unmanaged environments. You don't typically deal with native resources directly in your application, but understanding the differences between managed and native resources is crucial to avoid costly mistakes. Today, we're going to work with native resources manually, and we'll build abstractions to better understand and appreciate what .NET ecosystem provides. There are multiple ways to acquire a native resource. Typically, you might use pinvoke to call into native APIs, but in our case, we'll use Marshall class to manually allocate a block of unmanaged memory. The method returns an in pointer, which is a standard way to represent an unmanaged or native resource as an opaque handle in managed code. Let's look at how we can use unmanaged memory in our managed application. This method has three pieces. First, we need to allocate an unmanaged memory of a given size. The result of this call is an in pointer, which is an opaque handle that we can use to pass this memory around. For instance, we can pass this handle to an unmanaged code, and then we need to free the memory to avoid memory leaks. Instead of using Marshall class directly in our code, we can abstract things away. We can move this logic into a special type. So we can create a struct called a memory wrapper. The constructor of this struct is going to allocate memory, and then we'll have a release method that is going to release the memory. And so that's how we're going to use this. The code is quite simple, but it's still unsafe. If use memory will fail with an exception, we'll have memory leak. One option is to call the release in both try block and the catch block. Another option is to use try finally and release the memory in the finally block. But a better option is to make this struct IDisposable. This is a special interface with a single method called disposed that is going to clean up unmanaged resources. But the trick is that now the C# compiler can generate the code for us. So if we'll go into the IL code, we can see that our use native memory method has try finally block and calls dispose method in it. There are two common problems when dealing with unmanaged resources. One is memory leak, when you allocated the resources but never cleaned them up. Another one is when you clean up the resources more than once. Let's see what's going to happen if we just call a dispose method again, just by an accident. As we can see, the application actually crashes. And the framework design guidelines recommend that calling dispose multiple times should be okay. The first time we call it, the underlying resources should be released, and the subsequent calls should do nothing. So we can implement this. Let's speed this up. Let's complicate our example a little bit. Let's embed our struct into a class, let's create it, and let's call the dispose method twice. Technically, everything should be okay, because we have a defense mechanism that should allow to call the dispose method more than once. Let's check it out. But as we can see, the application crashed again. Let's look at the code. Mutable structs in C# are actually quite tricky due to defense copies created by the compiler in certain cases, such as for the read-only structs. And the resharper actually gives us a warning that says that an impure method is called on a read-only variable and struct value always copied before invocation. Technically, this code looks like that. So we make a copy of our struct, then we call a dispose method. And even though the dispose method changes its state to make sure that it's called only once, that state is gone because the state has changed in a temp variable, not in the field itself. Using a struct here is problematic for another reason. If we forget to call dispose method, can the CLR help? With the struct, the CLR cannot guarantee the cleanup, but with a class, we have an option. The GC knows when the instance goes out of scope and is eligible for the GC. What if we'll have a way to tell the GC to run our code to free up the resources in a specific way? And this is exactly why the finalizers were invented. The syntax is the same as the destructors in C++, but the semantics is very different. The finalizers are executed during the GC, and we typically don't control when the GC is going to happen. When a class has a finalizer, the CLR treats it differently. During object creation, the object is added to a finalization queue. And when the object becomes unreachable, the GC moves it to a different queue called a reachable queue during the first GC collection. And when the next time the GC runs, the finalizer is invoked, and only after that the memory is reclaimed. And this is the reason why you might have seen the following code. We call the GC twice. We call it the first time, then we're waiting for the pending finalizers, and we call the GC again. In this case, we will make sure that all the instances, including the finalizable one, are collected by the GC. And now we can test that our finalizers do its job and clean up unmanaged resources. So we create our memory wrapper, we use the memory, and we never release this. But we call the GC collection twice. So let's see what's going to happen. And as you can see, the memory was released by the finalizer. And we just saw how to create a managed wrapper for native resource. InPointer was representing a native resource, and our memory wrapper class is a managed resource. But implementing such managed wrappers is kind of tedious, and that's why the .NET has a class called SafeHandle, and lots of abstract classes derive from this. And here how we can make it. The implementation is much simpler. No finalizer, no need to handle multiple dispose calls, nothing like that. We just need to override one method and one property, and that's it. And we can run this version again to see that the memory is released exactly once. And as you can see, everything works as expected. The CLR is designed for managing memory for you, but it can do a good job with the resources as well. To use the resources in .NET correctly, you should understand the differences between native and managed resources. Native resources are represented via InPointer or something similar and are opaque to the CLR. Wrapping them in a class that implements IDisposable for eager cleanup with a finalizer for non-deterministic cleanup transforms them into managed resources. This distinction is critical. You should almost never handle native resources directly. It's delicate, tricky, and error-prone. Instead, derive wrappers from classes like SafeHandle to avoid writing the full implementation yourself. If you enjoyed this deep dive, hit that like button, subscribe, and let me know in the comments below what .NET topic you want me to cover next. That's it for today, guys. Thanks for watching, be curious, and see you next time.